Okay, so we're on unit 3 in this lecture, and we're gonna study preventive maintenance, how to do it. So if you recall the preventive maintenance, right, this little graph in the beginning, we study the cost at the optimum, the low, okay, system optimum. When it is low, we're gonna start doing the preventive maintenance, and that costs us less than to do repair and breakdown, right? Don't forget that. And so with an increase in the level of preventive maintenance commitment going that way, so the overall equipment effectiveness is going to increase, right? And the breakdown is going to decrease. So in this unit, we are looking at this little arrow. Instead, last time we studied right here at the top. And this time, we're going to look at this. So as you do more maintenance, right? Preventive maintenance, the repair and breakdown is going to go down. So we're paying attention to this line, okay? And the more you do the preventive maintenance, all right, the more the repair and breakdown is going to go down. And the optimum, all right, the system operation is going to go up, yeah? And we're looking at, right, this point of time, right? So I want you to, again, study the graph so you can be able to understand when you take a look at the lines. All right, if you don't study while looking at the lines, you're gonna be thinking this. You have a confusion in your mind, so don't confuse yourself. Try to look, pay attention to these little arrows. Okay, pay attention to how they're increasing, in which direction they're going. Okay, along with this relationship and the point of time. Okay, in this cost versus level of maintenance commitment relationships that we're studying. All right. So you can see in this maintenance cost comparison with non-linear preventive maintenance, okay, your PM. So here, the level of maintenance commitment is going to go up. And we're looking at two different, all right, curve for PM. One of them is going up, right, almost like an exponent, right, going up that way. So meaning like the cost is going up and you're putting more on the PM, all right, program. The other one is maintaining the cost at this. See how it's going straight like that, okay? They both are non-linear, by the way. And we are comparing the two. One is almost like an exponent. The other one is also, okay, going up first and then maintain at a very steady cost. Okay, this is cost. So some of the costs, all right, associated with PM activities, okay, they're going to increase. So the overall preventive maintenance, all right, cost is also going to increase. So if you have an increased level of preventive maintenance, what we're seeing, okay, based on this example graph, so the cost, all right, for preventive management, they don't always increase linearly. In some cases, they go this way. In other cases, they can be maintained at a particular cost. Okay? So that's what you're seeing between these two non-linear preventive maintenance cost versus the commitment level. So you can see in this example, the preventive maintenance, all right, costs it may decrease, right? It may decrease. Because if you take a look at this line, the very first line right there in the middle, if you do a particular, all right, less preventive maintenance cost program, you will be spending, all right, less money, less PM costs than this, because this PM program costs more than this one, okay, for the same level of maintenance commitment. The same thing right here, yeah. And here also, if you take a look at it here, the same thing, okay, there's a little difference right there. So that's what it's talking about in this paragraph, right? The causes associated with increased level of preventive management do not always increase linearly because of the way that you apply the PM. Okay, with the levels of preventive management and the causes associated with that preventive management may decrease, right, in some cases. But that's what you're seeing, more PM, less PM at the point of time where your level of maintenance commitment is right here. So here, the repair, so take a look at this repair and breakdown and this PM, yeah? You're spending the same amount of money for the PM, yeah? And your repair and breakdown, as you increase your commitment for maintenance, the cost is going to go down, yeah? Now continue to take a look at the repair and breakdown here too. If you do more PM, okay, right this point, yeah? And here you have a more commitment maintenance level with a low cost, right, of preventive maintenance. The repair and breakdown go down. See, it's going in this direction, going down. You have lower level of maintenance commitment, and then you spend more money, right, for preventive maintenance. And here, repair and breakdown, you also have to spend that much right there. Okay, so this level of maintenance is very critical. Okay, to if you go up, see, you can see right here, repair and breakdown costs go down because it's now at right here, and you will be spending less money for your preventive maintenance cost. Okay, going down from there to there. So that's what you can be able to understand when you study the repair and breakdown with preventive maintenance. So these lines and these intersection right there are what we're studying, right? PM and the cost for repair and breakdown and the level of maintenance commitment. And here this too, the nonlinear PM is just we're comparing, okay, if you put more or if you put, okay, a steady, all right, cost of PM program, and that is what you can be able to see at a level of maintenance commitment. And we're not dealing with the repair and breakdown for this comparison between two different preventive maintenance, all right? So there's two ways of looking at the same graph. But if you study the interaction, the more commitment you do, the less PM cost you will be using if you choose this type of PM. That this meaning like you're doing the routine, okay, PM, and the repair and breakdown cost will go down. Okay, all you have to do is to increase the maintenance commitment and use a particular, right, preventive maintenance, because we have many different preventive maintenance. So don't use this type of PM, use this type of PM to, and more commitment to bring down the cost for repair and breakdown. Yeah. So that decrease, along with other benefits of preventive maintenance, is going to increase. It will significantly lower, okay, the overall cost. So it will definitely increase the profit. Profit by saving the cost for repair and breakdown. Okay? So that's what it's saying. So the decrease is going to significantly lower the overall cost to maintaining that system. So in other words, right, doing a steady preventive maintenance, that cost, all right, the same is better than doing the PM with less commitment. Okay. Okay, so in this table, you can see the current preventive maintenance is low when you compare to the world class in North America. Okay, I have already shown you this one in chapter 1, unit 1. So you can see assembly, distribution, manufacturing, large and small, and process, consultants' opinions and weighted average compared to the world class. Okay, is low. Okay, so that's again the reason is because we have the ability to replace the components because we have the parts. Okay, and our decision making is we run the operation until it breaks and then just repair it instead of maintaining a program to watch the system. But the work, okay, manufacturing, they do watching the system and playing with the operation time instead of letting the component of the system breaks. Okay, so but this is pretty old data because the textbook use, all right, for this subject is this was like about some decades ago. So the current, all right, we're increasing the manufacturing sectors in the United States because of all this, right, the past decades. So we bring back the manufacturing facilities here into the United States to manufacture made in United States or made in America products. So along with that movement, you also have to increase the preventive maintenance, okay, activities. So in next decade, next few decades, you're going to see we will catch up with the world, right? Okay, so classifications of PM activity. So this is a facility that they are maintaining. Looks like a new nuclear system right there. So everybody protecting their self from the radiation. Okay, so we have a classifications for the preventive maintenance activities. So normally we have routine and we have a major preventive maintenance, two categories. One is a routine PM and the next one is a major PM. Okay, major PM is applied to system that you need to pay more attention. Okay, like this. Okay, so routine PM is a series of clearly defined and routine activities so that are normally carried out by the operator. So that's a routine activity, the boring one. And they usually go around and observe the system and check and then repair if they need to, replace if they need to, check the wear and tear. Okay, so your housekeeping, cleaning, inspection, you lubricate because the systems are made of non-living material. So industrial material you study, so you need lubrication, inspection, clean, and all the routine functions. So if you clean the system, okay, free of dirt, then your system is going to run in an efficient way. The next one, we will get into the routine. The first one is cleaning. So the first okay, step in the inspection. This is just a little car system right there that everybody has. So if you open, okay, the car engine and you take a look at it, if you see your car is dirty, it's full of dirt and grease, that means that you're not doing any kind of maintenance onto your car. You're just using it, okay? So make sure you opened, okay, your car engine and follow the cleaning instruction. You can't use the water, right? You have to use either the wipes, or if you do use a wipe, okay, water to get rid of it, and make sure that you don't disturb the metal part, okay, because there are different materials. So you can wipe the plastic part with the water, but it's okay, okay, they won't get rusted. For the metal part, make sure you use some sort of oil, okay, cleaning fluid or cloth, and to do the cleaning of your system, okay, for the car. But for the big system, then you're gonna follow, all right, the standard best practices that your company is going to provide you, and you will follow these steps, cleaning the component of the system, right? For the production system, manufacturing system parts. So that's what we do in cleaning. First, you detect, meaning like you're taking a good look at your system, and then you have to understand, okay, how your equipment operates in order to be able to maintain that system. So your operator's awareness is so critical in cleaning. Yeah. So that's our first step, is just cleaning, detecting the problem. Take a good look at your system. Second, you inspect. Go carefully looking at the system, broken or loose part. Check for the low level, right? Coolant. That's not for the car, that's for any manufacturing system, okay, component and equipment. So note any worn or frayed electrical wires. Again, they're all connected, okay? So therefore, these wires got to be connected in a proper way, logical way, okay? Detect, disable safety features. In operative or malfunctioning gauges, you have to detect lights, instruments, leaks. You have to try to find that, okay, if there's any, so checking. So these are all called the inspection, routine inspection that you do for hydraulics and other substances, trying to find the leaks. It's so important in order for the system to run. The system can run with one leak, two leaks, fine, right? But it's better to run without leaks. So you will check for all of that. And you're going to listen, because the system, okay, they always create noise. So listen to the sounds, excessive, unusual sound, rattlings or grinding sounds. So making hissing sounds, all kinds of stuff, right? So your system is in an environment. The environment is in the air anyway. So you will have to check, right, from part to part. So that's your job, inspection. Then go into lubrication. So there are many different kinds of system, from a very small, right, manufacturing system to really, really big, like NASA, okay, building a spaceship, components of the satellites, components of the measurement devices, like the telescope, right? So this is a very huge system that needs to be carefully maintained, okay, and lubrication is a part of the routine maintenance, because they're all made of material anyway. So here are a lot of metals, alloyed, different kinds of metals, and they rust, they oxidized, right? We don't want that. So the lubrication is important. Like even for the bio, okay, system, like our body, we have to lubricate, right? We have to lubricate, we have to put oil, lotion, all of that to protect our skin. Same as that, okay? Increase the EATs or SS lubrication points. Some of the lubrication points are difficult to go do the lubrication. So SS, all right, SS points are, it can be inside. So you have to use a particular machine or robots, all right, to get to those difficult to reach points. So reducing the types of lubricants by standardization is going to facilitate and encourage, all right, the practice. So we use many different kinds of best practices even to do this lubrication procedure. Okay, operator cannot do lubrication to certain component or certain system. Okay, we have to use a particular machine to do routine lubrications. Major preventive maintenance require longer periods of time because we care so much about the system reliability, and we don't want any kind of failure or defects happen in the system, so it takes more time. Yeah, so demand higher level of skills. So people, they need to know the system. The operators got to know the system and components. So that comes from education and also skills. And usually need schedule equipment shut down because you gotta take a good look at it. Okay, so therefore you can't run the equipment. You have to shut it down to do that maintenance, that kind of maintenance, major PM. And partial dismantling of the equipment, major overhaul or repairs, or replacing worn out parts and components. So that takes a little bit longer time. So we call that the major preventive maintenance, so degree and extent. And that's what we're looking at. And that depends on equipment history and the system criticality. Okay, how dangerous if you don't do this maintenance in that system. So always check the criticality codes. The system always comes with the codes. The more complex the system, the more codes you're going to see. And you have to follow the instruction, because if you don't follow the instruction, you will be jeopardizing the system and also putting yourself and other people's life in danger. Okay, it's a big system. You have to follow instruction. You have to do the right thing. You have to do listen to other people. Also apply your skills. How to be truly educated to understand that system. Okay, so not a joke. Okay. Equipment history. It's nothing but it's just a document. Okay, and we document the equipment life cycle and activities during that life cycle. So no meaningful, effective preventive maintenance program can be established without this document. Okay, and you need a clear understanding of the equipment history. So therefore we document them. So just by looking at reading the history, we come to understand that equipment or the system or the components in the system. So that's a very it's like a Bible, the maintenance management in the industry. Okay, so zoom in, and when you take a look at it, this is what is on that document. So here this is the equipment number in that system, and they installed that on this date, and this equipment is at this location. And what kind of equipment it is? A mill, a vertical mill, and the vendor is made by that guy. Okay, ACME Corporation, and it costs that much. So every equipment costs a lot of money in the system, so you don't want to mess it up, because if you mess it up, it will cost you your job. So therefore you have to truly understand and to be skillful and educated to maintain these equipments. Okay, all right, so then when you look at the document, you're going to see the history. On this date they did this, on this date they did that, on this date they did this. Okay, all right, so establishing and updating history. So for preventive maintenance, making and updating history, so this data is from purchases and also installation. Okay, to salvage, that means recover. It's a comprehensive equipment history for each piece of equipment. They have to show the purchase date, the equipment ID, and the vendor and location of the installation. Okay, I already showed you that in the previous slide. So the date, the extent is so important. That's just establishing the equipment history. So we're going to determine the reliability, mean time before failure, and availability. So when you look at it, in order for us to do this, we have to do that. First, historical data, the data generated from the completed work orders. Okay, for analysis of failure trends, that's what we do. For refining maintenance activities, for directing corrective actions, for determining our equipment improvement needs, for comparison of maintenance costs and replacement costs. So for this historical data, right, for your work orders, right, data generated from completed work orders is so important. And we do all of that, yeah, by using this historical data. Because if you think about it, in order for you to analyze the failure trends, you need the historical data. In order for you to refine or update or modify the maintenance activity, you have to take a look at your data, okay, what you did before. In order for you to direct the corrective actions, you need to know what happened to them before, yeah? In order for you to determine the equipment improvement needs, you have to know what happened before. In order for you to compare, right, the maintenance cost and the replacement cost, you have to know how much you used before, yeah, for each one. So the data is so important. Therefore, we record them, and therefore we file them, okay? Okay, system criticality. So since you are maintaining a system, the system can be very small and it can be very, very, very big and seriously, okay, important to maintain because it can, how can say, like, if maintenance, all right, failure happen in a system is a huge issue, okay, costs a lot of money to repair it. So therefore, you don't want to take your job carelessly, okay, lightly. You have to pay attention, and you have to know what you're doing. You have to know what you're doing. If you don't know, make sure you learn it, okay, before you do anything on it. So why? Is because there is a criticality, okay, in any type of systems. So the system, we usually classify the equipment, all right, depends on the degree of criticality. And that can be based on several factors. One is we determine by looking at the equipment cost, equipment function, redundancy, equipment safety, and then the history, okay? By using all of this data, we come up with the degree of criticality, and we call that system of criticality. It's just a classification. We classify the equipment. So we have 3, all right, code. So criticality code 1, 2, and 3. Don't confuse, all right, with the programming code. We're not talking about that. These codes are system, all right, big systems, physical systems, not a computer software code. Okay, this is a code that we use that you can see and read. So these degrees of equipment criticality, 3 categories, 1, 2, and 3. And that's number 1, your equipment, it has no backup. It's gonna cause, okay, or will cause bodily harm, alright, to people. Damage of other equipment, create a hazard to the environment, is gonna stop production, is gonna create a substantial financial loss, okay? That kind of equipment belongs to Criticality Code 1, right? We call it the dangerous equipment. So the preventive management should be designed to take care of that type of equipment, okay, seriously, in order to minimize these breakdowns. Because you don't have backup, and if the system or equipment fails, it's going to cause the bodily harm to the people around it. It's going to damage other equipment connected to it. All the components in the system are connected, okay, in some ways. It's going to create a hazard to the environment. It's going to stop the production of your system, the entire system. And it's going to create a substantial financial loss because of all of that. So therefore, that type of equipment, meaning like equipment component on the system, belongs to Criticality Code 1, dangerous, yeah? Second is Code 2. So the failure of Code 2 equipment, they may still create a loss or slowdown in the production, but the system can recover because the failure periods usually are short. All the spare parts for that equipment, right, substitute component backups, they are available, readily available for these pieces of equipment. So therefore, they belong to Criticality Code 2, less dangerous, yeah? So the preventive maintenance should be designed to minimize the number of breakdowns and shorten the breakdown periods. So this is our goal doing this program. So at the same time, keep the maintenance costs in check. All right. The next one is Code 3. So it's not frequently used, these equipment. And Code 3 equipment is sufficiently redundant because they have redundancy, meaning the backup is there, and or its failure seldom affects the production. Okay. Meaning like even if it fails, the production will keep on going. The PM should be, okay, the preventive maintenance should be minimal and then limited to the normal cleaning, inspection, adjustment, all right, for quality purposes. So we don't want to go into a big system because you wouldn't understand it anyway because it depends on different types of components. You have a car, so if you take a look at the car system, all right, Code 3 is kind of like a equipment of the cosmetic of your car, okay? Like your chair in the car or the seat, all right? Even if it breaks or whatever, it really doesn't matter. Air filter, right? Air filter belong to Code 3, okay? If you have like the powertrain, okay, and your suspension, so these will definitely go into Code, all right, 2, right? You can still recover, and all the loops, okay, battery Code 2, right? Because it's not going to cost you anything, but then it will interrupt, all right, the function. But if you have like a leak or a hole in the exhaust pipe, all right, that's critical, even if you can't really see, okay, because it would definitely stop your car engine, all right, it won't run. So if you puncture a hole in a gas, all right, line, thus belongs to that kind of equipment, all right, which is the hose, right, the connector between the gas, belong to the Criticality Code 1. Okay, seriously dangerous. It will explode the car, right? And it will damage the entire car engine and system. And also, it is harmful to the operator of the car and people around it. So that's how we categorize Code 1, 2, and 3. Okay, and when you take the car to the maintenance, a good maintenance or a technician would do 13-point inspection, and they will go through these critical, all right, Code 1 equipment first. Okay. All right. Planning for preventive maintenance. So equipment history and system criticality. So here is like, you can see manufacturing systems, and these guys belong to the maintenance, all right, department, and they're checking the pressure right here. So again, we do these checkpoints, all right, depends on the equipment history and then the system criticality. So it's all about prioritizing, all right, and you check what's the most important thing that you need to check so that the system uh, will not be interrupted because of the failure that can happen at these prioritized points in the system. Okay, so that's what we call planning for the preventive maintenance. We plan by using the equipment history data and the system of criticality groups. Okay, and we check these points in the system so the system will be safe and the system will be running at working condition. Okay, so another thing is we truly take care of the design, okay, for the maintainability. So when you take a look at the system design, it's got to include warning signals, right? So if you go back to your car engine, if you have a hole in your gas, all right, links, all the hoses, they're gonna show you, okay, code right there. And some of the cars are smart. It will shut down your engine, won't let you start even, okay? Most of the car will have a little blink, right? The exclamation mark is gonna appear right at your dashboard. And those are the warning signals that you have to pay attention. All right, and that comes from the system design. So the system design is built by the system engineer, and they think, okay, by using the prediction method, which is statistic, okay, and run a probability of all the events that can happen to the system. And then they design that system so that the system is intelligent enough to give the operator a signal to stop, okay, doing what they're doing if something wrong is happening in that system. And then again, it depends on the system criticality. All right, so the design has appropriate warning signal. The design, okay, so these warnings are for the audio visual, like bells, all right, lights. So you are aware, all right, of something is going on in the system. Also, the design got to warn, all right, the operator of the needed action, so the operator won't do something that is harmful to him or her or the environment. Okay, and it should be designed to protect itself as well. And the system must be designed, okay, to be simple and accommodating, so anybody who take care of it can be able to understand it easily. And the design, okay, must include and incorporate the concept of elimination, simplification, and standardization of main steps. So what it's telling you is for maintenance system, all right, depends on the design of that system. Okay, if the design isn't right, it's really difficult to maintain because you don't know when to maintain. Okay, you don't know where to take a look at it. So therefore, the system got to be built in a particular way to warn the operators and maintenance, right, people to be able to maintain that system, and we call that design maintainability. And it should come with the warning signals, okay, and it should protect itself, meaning like it's automatically shut down itself, okay, like the car. And it also got to be simple and accommodating. And it also got to incorporate these things, okay, so that you can be able to maintain the system. Okay, so that's it for the first part.